Hello, I'm Sumit Bose, and this is the Net Hero podcast. We've got the branding, we've got the hat, we've got the t-shirt. You can get some of those. Get in touch with us if you'd like to know it. But what it's about, what is it about? You know what it's about. Net Zero for Business. This podcast is about how businesses can help us transition to being better as a planet. Better business, better planet. We want to hear your views from scientists, from business people, from academics, from politicians, from you, the general public. So if you're interested in how we can try and cut our emissions, tune in, subscribe, join us. Now, on to this week's episode. How do we make ourselves more efficient? This is one of the things that I suppose is one of the cruxes of the net zero journey, and probably one that we don't think about as much as we should. We're all into kind of getting EVs, we're all into green power. Businesses are encouraged to, get into putting solar panels off. It's all about generation. But one of the things that we're very, very bad at is saving energy in the first place. Whether it comes to insulation, whether it comes to the way we kind of use materials, or, and this is a really weird one that perhaps you may have forgotten or may have never heard of, the way the current and the voltage comes into our businesses. There's a science which has led to a technology product which has been around for decades called voltage optimization. Now, many of you may be in the world of business and have already installed this. And many may be thinking, what the hell are you talking about, Sumit? This is really old stuff. It's not technology for the net zero future. Well, today I'm joined by Michael Lambert from a voltage optimization company called Power Perfector, who's going to tell us why voltage optimization not only is still relevant, but will become more relevant in our net zero future. Michael, hello.
Hello, good morning. How are you?
Very good, very good. Now, let's start at the beginning. What is, and bear in mind, you know how thick I am, what is voltage optimization? What is voltage, first of all? Because people hear about currents and amps and voltage, and we kind of will go, yeah, it's all electricity. Explain what voltage is and what a voltage optimizer does.
So what voltage is it's easiest to think about a water pressure or water hose. So voltage is a pressure of power into a business, into a building, which is then consumed by the load, which is measured in current, as you just talked about. Therefore, there's a simple calculation, which is where you get to kilowatt hours, and that's called consumption. And kilowatts hours, obviously, over a year you consume so much power, and that's how you build.
Yeah.
So we fit in that formula basically, and by optimizing your voltage from let's say UK average is 242 volts. By optimizing down to 220 volts in an efficient manner, using an efficient product, our customers typically see somewhere between 5 and 8% consumption reduction when you compare the 2 years.
Why do you get a consumption reduction? Because as you say, the voltage is the pressure. So we basically got more pressure than we need for most devices. Is that what the problem is?
Exactly that. And to your point earlier, voltage optimization has been in the UK now for over 20 years. And if you go back 20 years ago, we found when we were doing our trials that our sweet spot, if you like, by reducing to 220 volts, all the equipment operates more efficiently because you're just reducing that pressure effectively.
Why have we got the stuff at 240 if all the stuff runs at 220?
So part of that is down to the network constraints. So for example, if you're a farm out in the middle of nowhere, we've got volt drop across the system. So ideally you just have the network just turn everything down and happy days. But the reality is, of course, the volt drop over long periods of distance could result in that farm now having too less of a voltage supply.
So what's happened is, I assume this is a kind of set thing across the UK. Someone made a decision to say, this is the optimum sort of power, the pressure, to get everyone enough supply to run things.
Yes, it's called European harmonisation, and it was back in 1996. And effectively what happened is, as part of Europe, we agreed that our power supply should be 230 volts plus 10%. In the UK, minus 6%. Europe was minus 10%. So that gets you somewhere between 216 and 253 volts. And that's what the network have to provide.
Right.
But the reality is, of course, our voltage isn't 230 volts plus 10 minus 6, we're already up at 242 volts as an average.
Why have we got an issue then in terms of the pressure, as we call it, the voltage, making a problem? You said earlier, by reducing the voltage, by optimizing it, machines, electronics run better.
Yep.
Can you explain why, I don't know, the light I've got here right now, if it's actually running at 240 when it needs 220, why is that a problem for that light device? Why is it a problem for my monitor?
So it's not really, as I mentioned, the European harmonisation. So what that meant actually in reality was that manufacturers of electrical equipment that supply to any part of Europe and the UK have to enable their product to work from 207 volts to 253 volts.
Okay.
What we've found is that by operating equipment at 220 volts, we see an energy saving from when you operated at 242 volts.
And what about the long-term life? Because I get the thing that if you're adding more pressure to a device, eventually that's probably making that device work harder than it needs to.
Yes, absolutely, and it's really hard to measure as well.
Yeah, I
and
was
it's
gonna
not
say.
through a lack of trying. So we've got anecdotal stories from some of our customers, particularly the guys that work in the maintenance arena. I had one hotel maintenance manager tell me that pre-installation he was running around changing his LED ballast all the time. Post-installation, he's now not changing his LED ballast as much as he was pre-installation. But of course, to measure that,
Yes. So it's very difficult to actually quantify directly, isn't it?
exactly, yeah. You'd have to know how many LED ballasts you'd consumed the year before and how many you'd consumed post-installation. And obviously, customers just don't have the sort of time to put to give us to work that sort of stuff out.
Okay, so we now know what voltage is and we know what devices use, and we're probably overpressurized. That makes sense. I think most people can get that. So what does a voltage optimizer do? And what is it? Is it a box? Is it a kind of like a big transformer? Is it huge? Is it small? How does it fit into a business?
So the easiest thing to compare it to is a transformer.
Right.
Everyone sees out on the streets.
Yeah.
Grey boxes. It converts one voltage. It's actually a high voltage to a low voltage. A voltage optimizer is a three-phase product, and it reduces the voltage from, as we said, let's keep it simple in single phase terms, 242 volts to 220 volts in the same manner as a transformer. But the big difference with voltage optimizers, and you'd expect with the products that are available, is that they're highly efficient. So ours, for example, is 99.96% efficient across its operating range, as opposed to if you go back to those grey boxes, and let's say we used a sort of old style transformer, they weren't designed to be efficient. So depending on how heavily loaded or low loaded they are, depends how efficient they are. As with our product, is designed to maintain that efficiency irrespective of its load condition.
Do these devices, I mean, it's the word that everyone uses, are they smart so that they can ride the current, ride the voltage that's coming in and go, actually, well, today it's really high, we'll knock it down a bit more? Or do they just set and go, right, 242, it's always going to be 220?
So really good question. There's two products available in the market. We'd refer to it as a standard voltage power optimizer. And what that does is, let's say it's 242 volts on the incomer, and you set it at 8% to achieve a 220 volts. As the incomer changes, let's say it goes up a volt, the output voltage would go up a volt. So it follows it.
Okay. So it maintains at the level depending on where things are?
No, not quite. So as the input voltage goes up, the output voltage goes up with it, and it follows it. But the product that you can then sort of upgrade, if you like, would be to put a controller of the output voltage on. So, for example, we had what we called an automatic voltage controller. We've had that available since, probably about 2004. I think that first came into use. And what that does is it controls the optimizer's output relative to the input. So we've spent quite a lot of time and effort developing a newer product which does exactly what you were talking about there. Is we maintain 220 volts.
Gotcha.
Irrespective of the voltage change.
So it doesn't matter what's coming in, and it'll keep that 220 in that steadiness.
Yeah, 220 volts, and it's it's super precise. So it's about half a volt variance, if that, which is something like 0.000%.
There are several companies doing all this. Is everyone set at 220? And why did the industry choose 220 as the kind of output voltage?
I suppose from the marketplace that I've seen, most providers are around the 220 volt mark. The reason we've used 220 volts is because that's basically that's where the science took us. We
Right.
found if you start reducing less than 220 volts, in certain applications, that is, your kilowatt starts to slope back the opposite way. So there's a sort of fine balance, and like I said, we're 220 volts plus or minus a few volts either side is where we want to be. Interestingly though, because the other market to think about is the domestic market.
Yeah.
What we found in the domestic market, and it's not something we provide at the moment, is that you can keep reducing that voltage down to the sort of 210 mark, and actually you achieve more savings. But in business world, in the sort of types of equipment that we operate in the business world compared to home, again, 220 volts is where we want to be.
If we go back 10, which the first time I heard it was about 15 years ago, pretty much when we started. And it was one of those technologies that people said, oh, yeah, it's quite important because we weren't as efficient in those days. Fridges weren't, lights, people still were using incandescent bulbs, not LED lighting. Computers, everything, doesn't matter what it was. There was always that thing that the products were much dumber, for a word, than they are today. So in that time, voltage optimization was seen as a good thing because it allowed people to get some energy efficiency. Since then, products have got smarter. Have people said that they don't need optimization as much? Have you found that?
Absolutely, we have, yeah. And we've been back to some of our customers from a decade and longer, and we did a really interesting trial with one of the food retailers, which has opened up, I suppose, the marketplace for us again, where they actually said to us, look, Mike, we've done voltage optimization a decade ago. It's done its.
You're yesterday's man, Mike. That's what they were saying.
It's done its thing. It's paid itself back,
Yeah.
But we just don't believe it adds any value today because we've got energy efficient refridge packs with glass doors on. Insulation is much better. We've got LEDs now. All the energy efficient measures that you'd expect any sort of growing business to have. So we said, well, I'll tell you what, why don't we'll prove that the voltage optimizer, which you installed over a decade ago, is still adding value. So we did we used what we call a voltage bypass switch. So we could turn the optimization effectively on and off. So we did that over an agreed testing period at two of their stores, and we saw between 5 and 8%.
Even with the more efficient products and devices we've got now.
Exactly, yeah. And it was the optimizers that were installed, like I said, over a decade ago. So that's now led on to we then did another 5-store trial with new installations on old, doing the same thing, and again saw the same results between 5 and 8%.
What did your customers say when you said this? Because it must be difficult because you kind of think you've done it, and I get it. Businesses do capex and they go, right, we've done that, we've put this in, we've now got smarter, and everyone's being flogged products that are smarter and cheaper and better efficient. So you kind of forget that sort of earlier stage, don't you?
Yeah, exactly. So the food retailers, 3 of them have now sort of after the trials and demonstrations are now implementing that across the rest of the estate with all the stores that weren't done back in 2007 to 10. Obviously, it's good business for us, and they're getting their energy savings at a high level now, especially when you consider the energy price as well.
Yeah.
A decade ago, the energy price was, I don't know, probably about 6-7p. And, some of our customers, at worst, we've seen paying up to 60 pence per kilowatt hour. So if you can get 1% saving,
it's a big one.
Yeah, exactly. One of our other customers, I say only, we expected them to see a 3% energy saving through optimization. And again, that's because of the load mix and their energy efficient measures. But 3% with the energy price that they've got is an attractive.
No, of course it is.
Yeah, exactly. And that project's progressing. So yeah, it's brilliant. But 3%. Sorry, the point I'm making is 3% a decade ago wouldn't have gone anywhere. It wasn't interesting anymore.
Yeah. I want 15-20% off. Yeah, absolutely. Yeah. One of the things, before we talk about where its future is, the kit, how expensive is it for a business to to start on this journey if they haven't done it? I mean, and also how disruptive is it? So say you're, I don't know, a factory or whatever, and you go, right, I've got machines that are working on a supply chain line, we've got kind of conveyor belts, you've got fridges or whatever. Do they have to go to get you guys to, well, hang on, guys, we're going to have to go right to where the power comes in, stick a big box in? How much disruption is there? Is it very expensive? What's the payback? Because these are things that kind of, particularly in this time when people are being offered different ways of energy saving, this might be one of those things that people go, well, do I really need to do? Is there a financial case to do it?
Yeah, indeed. So let's talk typically, I suppose. Our customers we would expect to, with the energy prices that we've got nowadays, they would see somewhere between an 18-month return on investment up to about 2.5 years. Again, you go back a decade ago and it was can we get a 3-year payback? Because of the energy prices.
It's quicker now.
Yeah, a damn sight easier to achieve.
And disturbance,
In terms of interruption, yeah. And actually, this is one of the things that I used to sort of scream about with particularly the maintenance guys, is that actually whilst we need a shutdown because the optimizer is installed in series with the main incoming supply and therefore the load, it's right at the front and the heart of the building, if you like.
So it sits where the power's coming into the premises.
Exactly,
yeah.
Pretty much downstream from your meter. So yes, we do need to do an interruption, but it's typically somewhere between, again, depending on the size of the building, 3 to 6 hours is what we say to our customers. Yet in some of the food retailers that we're doing, it's less than 2. The other thing you can do, of course, is to manage things like refridge packs and things like that, is we can do the installation over, I don't know, an 8-hour period where we're only doing 1 hour shutdowns and then an hour back on.
Yeah.
So actually, it's the interruption, whilst everyone sort of takes a deep breath on, oh, you need to turn my power supply off, can easily be managed with good project management.
You said you've been in it 20 odd years nearly, right? So
yeah.
If you go back, and we've just been discussing, money was the thing. And I'm not saying money isn't, but the world has changed and people are looking for a carbon saving as well now in anything they do, because that's where we're trying to get to cut our emissions. So can you explain why Voltage Optimizer could save you carbon? And if so, how much carbon, if you've got an example of how much it could do?
Yeah, absolutely. So if you make a kilowatt hour reduction through voltage optimization, so let's just say it saves 5%.
Right.
There's a conversion factor from BEIS where they say...
Or DESNES as it is now, isn't it?
I can't keep up.
No one can keep up. Call it DEC again.
yeah, all that. So let's say they've got a conversion factor which says 1 kilowatt hour equals X amount of CO2.
Gotcha.
It's around 0.2. I think it's 0.18 at the minute, and that gets reviewed at least annually.
Right.
So therefore, let's just say we've saved. I'll give you a good example of the tea manufacturer that we worked with. We saved them 5.04%.
Right.
To be entirely precise, which equated off their energy bill of about 215 kilowatt hours.
Right.
That's converted using that conversion factor I've talked about, and that resulted in them therefore saving 38,641 kilograms of CO2, or put easily,
38 tons
over that year.
So you can now give a person a reason in carbon terms why this technology, which many people think is quite old, is still relevant.
Yeah, absolutely. So basically what the tea manufacturer said was this: we consumed 200,000 kilowatts of power last year. We expect to consume the same amount next year. We've applied a voltage optimization unit, and by doing so, I've saved year on year, I've saved 38 tons of CO2.
Where do you see the role of this in our new future? As we get more flexibility, as the grid decentralizes, we are going to have more, I suppose, I wouldn't say we're going to have interruptions, but the grid will have to cope with the diversity of where power generation comes from. We're not going to have that big base load anymore. So you're going to have battery storage, you're going to have things like that. Do you think the optimization technology, optimizers, have a role to play in our more kind of greener grid future?
Yeah, absolutely they do. And I think both types of product, either the controlling optimizer, if you like, the electronic version, or the standard optimizer, both have parts to play. I also think that what we need to unlock is how we apply it to the network. That would make it a lot easier. Again, we've done some R&D work on how you could apply voltage optimization on the domestic load. So rather than installing an optimizer on every single house,
Yeah.
in every single house, why don't we optimize the substation at 11,000 volts down to 415, then put your optimizer in. And if you can control that optimizer, it makes obviously the homeowners all benefit, the networks benefit because
They not have to dig up or put in. Yeah,
we're all
got it.
consuming less power,
Yeah.
therefore they have to dig up that cable now to replace it. And we did some interesting work with UK Power Networks back in 2018-19 as a part of the as an Ofgem sponsored project to reduce capacity on the network. It's just not gone anywhere, unfortunately.
Why do you think that is?
I think part of it, if you so, there's also an electricity standards review that happened in 2020. Yeah, it's just pre-pandemic, and part of it is there's so many people involved. You've got the transmission operators, you've got the network operators, you've got the metering operators, and I suppose getting everyone to agree that actually we could run our grid at 220 volts in the right places, not entirely across the entire grid.
Yeah, yeah.
It's just going to work back to the farm example I talked about earlier. So it's getting everyone to collaborate. The network guys would say, well, how do we control fault levels?
Yes, that's the big thing I was going to say.
Yeah.
Yeah.
So you then get into all those technical conversations, and I suppose for me it just becomes hard work, but it really shouldn't be hard work because we're sitting on an ability to reduce the consumption for the whole of the UK by applying voltage optimization.
And I know there are other players apart from your company out there. So how big is the voltage optimization market right now? How many kind of business properties would you say that have got a bit of this kind of kit in across the country?
It's relatively across the UK. It's tidy, and we haven't
Tiny,
even
right.
scratched the surface. So we, with Power Perfector, we've done over 7,000 installations across the UK. So let's assume the other providers have done similar amounts. It's probably about 20 to 30,000 optimizers there in the UK, and we've got hundreds of thousands of substations.
I bet. So we must have, well, probably millions of premises that we could
Yeah,
put this
exactly.
in. Are we behind this curve on this? Are other nations doing this, or is this just kind of standard across the world?
Across the world, we haven't seen anyone that's applied it on the networks that
Right.
we've just talked about.
But is there a bigger rollout of these optimizers in certain countries than others?
Yeah, so our product originated back in Japan, which is partly why it's as robust as it is, because it was designed for earthquakes. And in Japan, Southeast Asia, there's over 180,000 installations that
Wow.
we're aware of, and obviously the other providers. So we're behind the curve in that regard.
But Europe's different? We're about the same, or?
Europe's slightly different in that, again, our experience is if we've got a really good distributor out in France, they see 230 volts, and it's a really good question actually, because 240 volts as their average, and then you go to Poland and Germany where we've done some other work, and they're at 230 volts. The difference therefore between the two is that the amount of optimization, the quantity, if you like, if we're optimizing by 8% in the UK and France, Germany and Poland would only have an ability to optimize by 4%.
Gotcha. Yeah.
You'd like to think there's an easy conversion, which there isn't, to savings. So half savings. It's not quite as simple as that, but let's just say it is for the moment. Therefore, the return on investment is now 50% harder out in Poland and other parts of Europe.
Is this the problem that you have with optimization? The technology works. It's been around a long time. I could do it tomorrow, all of that. But there may be ignorance in the market. I've just shown you that my ignorance on it. And also there's a complexity of kind of where everyone's thinking of future tech. It's really hard to try and sell in old tech when everyone goes, what's the next thing that's going to, cut our power? What's the next thing? I'm trying to get to why you think this hasn't gone where it should have done if it's been around this long.
Yeah, so one of the hardest parts of voltage optimization and where the skeptics jump in, and obviously in my job, I address that quite often,
I bet you do.
is prove how do you prove the savings? Because it's
Yes,
not like a car, right? You're driving along, you're on a flat road, you're consuming 38 miles per gallon, then you go uphill and now you're doing 20 miles per gallon, and that's a little bit like a building, isn't it? So how do you prove that when your building's at full load, it's saving 8%, and when it's at no load, it's also saving 8%?
correct. Yeah.
And one of the ways that we came up with the food retailers was to switch, like I said earlier, to switch it on and off.
Yeah, but that's not the way to try and do it, is it?
Effectively, by switching it on and off, you've then got to buy into the fact that it is saving energy.
Yeah.
So again, we'll come up with an average. Let's, like I said, at the tea manufacturer, we had 5.04% as the average, which means that at some point it was only saving 1%, and at another point it was saving 9%. It's all to do with the equipment that's on at the time. So that's where the skepticism comes from, and it's about buy-in from the customer, really. And again, like I said, we've spent a lot of time not convincing, that's the wrong word, but demonstrating to our customers why we're seeing the energy savings we're seeing, or not in some cases, because there is places, let's not forget about that as well. There are loads that shouldn't have voltage optimization
Of
applied.
course. Yeah. So it's not for everyone, this technology.
Correct.
Yeah. Do you think it could, if we had a wider rollout, it could make a big difference to the carbon? Because what it would do the efficiency before the efficient products in a way.
Yeah. And that's another part of, I suppose, why not, is that one of the sort of skeptical views I've got is that by reducing the amount of power the UK consumes through voltage optimization, you've reduced obviously all the revenues as well. And but that's part of the challenge as well, because of course the network operators and the meter operators, they need to make the money to continue all the development. So it becomes more difficult.
Do you kind of think you're flogging a dead horse, or do you think actually you just got to go out there and tell people this is a robust, salient, and future-proof technology that actually gives you good return? You could still do this; it's still worth doing. Or do you think kind of it's really very small percentage of people still continue to use it, and that'll be it?
Well, if it's if it's about flogging a dead horse, I've been doing it for nearly 20 years.
You chopped it into pieces and been selling it on.
Yeah, I'm still doing it. I absolutely believe in voltage optimization. It's got a part to play in the UK and wider
In our net zero journey.
Exactly. The new tech that we've spent a lot of time and effort developing to be a controller is the intelligent bit that intelligizes, if that's even a word, voltage optimization.
Smartens it up. Yeah, I get it.
We looked a few years ago with National Grid on a project where we were looking for, it was at the time when they were doing frequency response and
Yes.
enhanced
Yeah.
response, which is about speed. And we were working out, well, if you applied our new electronic product to all of our optimizers in the UK, and you could switch them on and off fast enough, you can actually you've now got control of demand side response, if you like. You can get sites to consume more by putting the voltage up, and you can now get sites to consume less by turning the voltage down. If you do that on the UK network, happy days, you've got control of the network at the low voltage point, the 415 mark or 230 volt mark, 240, as opposed to at the moment, we've got no control on the LV side. It's all done on the transmission side. So voltage optimization placed right in the right place can offer you a lot of voltage control easily.
Last thing I want to touch in, new technologies are coming, you know that, right? New batteries, new technologies in terms of the types of batteries and how they'll work. Solid state stuff is coming. Can you see this kind of slightly older tech, let's call it what it is, solid tech of an optimizer fitting in with our newer techs that are coming in the way that we move to more battery storage?
Again, yes, absolutely. you're back to two options again, aren't you? You can either do it through the fixed optimization because it's in the right place, or you do it through an optimizer with a voltage controller sat next to it to control that voltage. And again, by having that voltage control, you can reduce or consume more. So yeah, I think it is entirely right. The other point to make, of course, is that we're doing this on the low voltage side of the network. A lot of your wind and solar farms are all on the transmission side or feed in on the transmission side, which actually don't help us downstream because of the variance that gives. And we have seen the UK voltage from, again, our 2 decades of being around, is creeping up. And a lot of people think that's creeping up because obviously the generators or your green generators have to push the voltage up higher than the mains voltage to get the output in the first place.
To get the output, yeah, absolutely.
Put an optimizer at sort of the end of the pipe, if you like, and we've now got control of that. So it doesn't matter. They could keep pushing it up because we can optimize relative to their output downstream. So yeah, it should entirely sit there.
Optimize now. That's the message.
Yeah, exactly. do it now.
Mike, thank you so much. I really enjoyed this because I think it is, I wanted to talk, we talk a lot about new technologies on this podcast, and we talk about kind of what's coming, but I do think that this energy efficiency side is one thing I really wanted to address. So thank you very much for your time.
No, it's been a really interesting conversation. Thank you.
If you have an opinion on voltage optimization, maybe you've done it, maybe you're thinking what this could be, then drop us a line, get in touch. You can do so on social media or email the show, nethero@futurenetzero.com. And remember to visit futurenetzero.com for all the news on things such as voltage optimization and new technologies to try and drive your carbon emissions down. Catch you next time.
You've been listening to the Net Hero podcast with Sumit Bose from Future Net Zero. Visit our platform for all things net zero. And if you or your business is doing great things on the path to net zero and want to be featured on the podcast, email nethero@futurenetzero.com. Follow us on social media. futurenetzero.com. Better business, better planet.